Nuclear power, also known atomic power. Before viewing this short video, you, the audience, might be unclear about the seemingly convoluted process of harnessing the power of atoms for electricity, so get ready to clear your minds as I explain how the sustainable source of power functions. In short, a lot of science. In long, the process of nuclear power arguably just boils down to a basic principle, using pressurized steam to spin a turbine, which in turn spins a generator, converting the kinetic energy into electricity. This method is commonly used by nuclear power plants because of its basic simplicity and its affordability. This process was also used commonly by 19th century steam-powered locomotives. These trains achieve motion through a furnace using coal as fuel. It produces enough heat to boil the water stored above it, a bit like a kettle. The steam from the boiled water is sent down a dense tube, maximizing the pressure, until it reaches a tight cylinder piston. The piston is pushed out as the steam expands, thus pushing forward the wheels. Once this use of pressurized steam has been expended, the piston moves back to its original position, so the cycle can begin again. Nuclear power follows this same method, except the piston is replaced with a steam turbine, and the coal is replaced with uranium-235. So how does one use the heat from uranium atoms to boil water? I mean, you can't just put a match to an element with a melting point of over 1000 degrees Celsius and expect it to burn. That would just be silly. No, the real process of using this heat is a process dubbed nuclear fission. The process, in simple form, works like this. The uranium atom's nucleus, or center, is bombarded by neutrons. The atom will absorb these neutrons, creating an unstable and unpredictable reaction. The most common of these reactions will cause the uranium atom to split into different, less densely packed elements, releasing a large amount of energy which will heat the surrounding water. As the atoms split, excess neutrons will in turn strike and affect the uranium atoms, increasing the level of radiation as the cycle continues. But this complex process can't be used for every single atom, such as a simple hydrogen or lithium atom, for an understandable reason. Atoms, such as uranium and plutonium, have copious amounts of electrons and protons, making them extremely unstable and prone to these nuclear reactions. And that, in an irradiated nutshell, is how nuclear power works. But there are still many more questions that have still been left unanswered. Could these nuclear power plants put us in a scenario comparable to that of Terminator? Why is this form of power sustainable? What mad genius could have thought of this complicated process? The answers for these questions will be presented shortly.